Hello, here are two examples of simultaneous equations as we did in the lesson on Thursday, just to remind you in case you're not quite sure. I'm going to start with the one on the left. 4x plus 3y is 37 and 2x plus y is 17. Now the very first thing I need to check is whether we've got a matching pair of coefficients. That means the numbers before the x or before the y are the same. So the coefficients of x are 4 and 2, not the same. The coefficients of y are 3 and 1, again, not the same. So I need to do something to one of those equations to make them the same. Now what I'm choosing to do is I'm going to look at the second equation, and I can see if I multiply that one by 3, I'll get matching coefficients of y. They'll both be 3's. So let's just rewrite the first one out again. So I'm not changing this first equation at all. But I am now going to multiply every term of the second equation by 3. So that would give me 6x plus 3y equals 3 17s are 51. Notice that I've multiplied the 2x, the y and the 17 by 3. I must multiply everything by 3. Now I've got my matching coefficients of y, so I can just subtract those equations and I'll eliminate the letter y. So 4x take away 6x is negative 2x, 3y take away 3y is nothing, and 37 take away 51 is negative 14. So now I just need to divide both sides by negative 2 and I get x is 7. I found the value of one of my variables, one of my letters, but now I need to go back and find the other. So I'm going to use the second equation, 2x plus y is 17. 2x, when x is 7, is 14. So 14 plus y must be 17. Therefore, y is 3. And I've solved my simultaneous equation. Right, moving on to the next one. I've got 2x plus 5y is 15. And 3x minus 2y is 13. Now, if I look at the coefficients of x, I've got a 2 and a 3, not the same. If I look at the coefficients of y, I've got 5 and negative 2, not the same. Now, it's not quite as simple as the first example. I can't just multiply one of the equations by something to get matching coefficients. I've got to multiply both of them. So what I think will probably be the easiest, if I look at the coefficients of x, I've got a 2 and a 3. I'm going to aim to make those both 6. So I'm going to multiply that first equation by 3 and the second equation by 2. Okay, so I'm going to write out those again. Let's just go back to black. So if I write those equations out, the first one I'm going to multiply by 3, so I get 6x plus 15y is 45. The second equation I'm going to multiply by 2. Remember every term, so 6x minus 4y is 26. Now I've got matching coefficients of x. I've got a 6 and a 6. So I can just go back to what we were doing in the lesson yesterday and subtract. So 6x take away 6x is nothing. 15y take away negative 4y is the same as 15y add 4y. So that is 19y. And 45 take away 26 is 19. So I can see that y is 1. Be careful when you're subtracting negatives, particularly here. 15y subtract negative 4y. If I subtract a negative, I am in fact adding. So that's 15y plus 4y, making my 19y. Right, so we found the value of y. We need to go back and find the value of x. So all I need to do is choose any of those equations. I'm going to go for the very first one. So 2x plus 5y. Now if y is 1, 5y is 5, is 15. So that leads me to know that 2x is 10. If I subtract 5 from both sides, divide both sides by 2, so x is 5. And I've solved my simultaneous equation.